Hello everyone, today I will talk about using iterative method to solve the binary tree maximum path sum problem. In previous video, I used the recursive method to solve this problem. The video link is below. However, in Python, the recursive implementation is not very efficient when handling very large trees. To overcome this problem, I use iterative method here. In this method, we use one stack. The idea is to move down the leftmost node using left pointer. While moving down, push node and node's left child to stack. Once we reach leftmost node, we update maxsum and node value accordingly if it doesn't have right node. If it does have a right node, we change the node so that we can look at right child. Let's see this example. First, initialize an empty stack. Then start from the top of the tree. Push 6 to the stack. 6 has a left child 3. Push 3 in. 3 has a left child 1. Push 1 in. 1 is on the top of the stack. It has no right child. Pop 1 out. Update the maxsum 1. And the node value to be passed up 1. 3 is on the top of the stack. 3 has a right child 5. Push 5 in. 5 is on the top of the stack. 5 has no right child. Pop 5 out. Update the maxsum. Since 5 is bigger than 1, so maxsum is 5 now. And the node value to be passed up is 5. 3 is on the top of the stack, and its right child 5 we just visited, so we pop 3 out and update the maxsum at the node 3. 1 plus 3 plus 5 is 9, bigger than 5, so maxsum is 9. And the node value to be passed up is 8, because 3 plus 5 larger than 3 plus 1. 6 is on the top of the stack. 6 has a right child 12, push 12 in. 12 has a left child 10, push 10 in. 10 is on the top of the stack. It has no right child. Pop 10 out. Update the maxsum. 10 is larger than 9, so maxsum is 10. The node value to be passed up as a node 10 is 10. 12 is on the top of the stack. It has no right child. Pop 12 out. Update the maxsum as a node 12 is 22. 10 plus 12 is 22. The node value at 12 is also 22. 6 is on the top of the stack. Its right child 12 we just visited, so we pop 6 out and update the maxsum at node 6. 8 plus 6 plus 22 is 36. 36 is larger than 22, so right now the maxsum is 36. And the node value at 6 to be passed up is 22 plus 6 is 28. At this time, the stack is empty, so we found the final result is 36. That's the end of our search. So let's look at the code now. This line is to initialize an empty stack, and this line is to initialize the max sum with a negative infinity. This line is to mark the node we have visited. This line is to check whether we have visited all nodes in the tree. These three lines are to push the node and node's left child into the stack while moving down to the tree. This line is a look at the node on the top of the stack. This portion is to update max sum and node value when that node has no right child. This portion is to update the max sum and node value when we have visited its right child. And this line is to look at the right child when the right child is not visited. Before ending today's talk, I want to mention one important thing. This code modifies the binary tree original node value. To avoid it, you can use list to store max sum and node value, but I will leave you to figure it out. Okay, that's all for today. See you next episode.